Hi, today I'm going to be solving the 4th of January 2021 Slitherlink, and I'll put the link to it in the comments just below so you can click there and easily find the puzzle on Puzzle Mix to solve along with me. So here's the puzzle here to my side. As you can see, I've turned on the highlighting option, which allows me to automatically colour in green clues that are already solved. In Puzzle Mix this is show valid, invalid placements. So essentially I already know that there's nothing round these, because the aim of the Slitherlink puzzle is to draw a loop which goes round each number as many times as the number is equal to. So for example, a 3 needs to have 3 sides around it, a 2 needs to have 2 sides, a 1 needs to have 1 side, and a 0 has to have 0 sides around it. And in Puzzle Mix I can use an alt click or the right mouse button to mark an edge of a number as definitely not part of the loop. So for example, with these zeros here, if I'm putting in the edges, I'm just reminding myself that there's definitely not any part of the loop there. If there was, to coloured it red, it would be wrong. So where do we start with a puzzle like this? Well, I think that often the 3s are really helpful. A 3 in a corner is useful for a start because we have to visit both of the edges that go into the corner. And you can see why that must be the case, because if we didn't, then at the most, even if I use both segments, we haven't got 3 edges on it. So because it goes into the corner and we need to form a single loop without any dead end bits that go off on their own, then it has to go in and out the corner, so we know those 2 bits are used. And similarly, anywhere you end up effectively with a corner, like next to this 0 here, because if this goes here it has to come straight back out because both of these edges are blocked, then you can do something similar. I know it uses these 2 bits of the 3 here, and indeed over here, because there can't be a line coming in here, it couldn't get out, there must be 2 edges here. That's just the way Slitherlink puzzles work. So 3s are really helpful to start with. And 3s next to one another are also useful. If we look at these 3s at the bottom here, for example, then no matter what happens, these 3 line segments have to be lit. And you can see why that might be. If this one wasn't, we'd have that, which would lead to this situation where we've created a loop. Okay, so if your puzzle just had 2 3s and was otherwise totally empty, then you could have a different solution. But in the usual situation where you have many more numbers than that, this is definitely not going to be correct. So you can mark in this. And similarly, you know it doesn't go off to the side, on either side, because if it did, you wouldn't be able to complete the other one. It would be impossible. So you can mark these bits as X's, or not used by the loop. So similarly for this 3 here, and there's another 3 in a corner, and these 3s here. Now what's quite interesting is that when you have, and in fact these 3s here, what's quite interesting is that when you have 3s diagonally opposite each other, I'll just get rid of this line for now, then they must always follow this pattern. And you can experiment and work out for yourself why that must be the case. But I mean, briefly speaking, if they were like that, you wouldn't be able to complete the other pair, so you must have the 2 oppositely lit segments. And then of course we've also got what we already knew from the 3s, horizontally and vertically next to one another. And now we've drawn this in and marked this bit as empty, then we know for a fact this must be marked in. So we've completed both of these 3s already, and it's helpful, I think, to mark in, at least when you're learning to solve, the square segments that must be empty. In particular, this makes it now clear that this 2 must be solved like this, and because the loop has to connect, it must come out like that, which in turn allows us to finish all of the segments required for the 3, because we couldn't do that because the loop would be splitting off. It wouldn't be a loop anymore. It would be a series of paths. And this 2 here must be connected like that. And in fact, what's interesting about this is that the loop must come up here, so it has to go either this way or this way. So it has to be one of those 2, which means it is not there and it is not there. And although in this case that may not actually be very useful to mark these in general it's a good idea to mark in everything you know, because that's how you make progress, by looking to see where you've narrowed down options in the grid. Now one thing that is also worth looking at early on is 2s in corners. So for example, this 2 here is in a corner because it has to, if it comes in here, it's not going this way, that's a dead end. And similarly there's 2 in a corner here. And in the 2 in a corner, it either goes through the corner one way, or it doesn't enter the corner at all, and it goes the other way. So the situation is, it's either like that or like that, because it can't do that because it would get stuck. There's no other possibility. If I was solving on paper, I would draw a faint diagonal line here to remind myself this loop must connect here. But using an online solver like the Puzzle Mix one, I do at least know that the loop comes in and out of those corners one way or another. I just don't know if it goes that way or that way. But I do know that this bit is lit and this bit is lit, which means, for example, that it must go round the 3 this way or round the 3 this way in this particular puzzle. And in either case, both of those segments are part of the loop. And I can mark these as not part of the loop because we can't have the loop splitting off. So we're starting to make progress. We've already marked in quite a few things. Let's see what we can do next. So I'm going to mark in a few more of the edges that I know are definitely not connected. Right, so this 3 here must continue here or here. Either way, it's one of these 2 bits of the of the 1 rather. So these bits are empty. And now once I've marked in that these loop segments are empty, I know that the 3 must use the other 3. There's no other option, which forces the connection here and indeed here. And now the loop can't stop, so it must connect outwards. And I know that these 2 don't connect directly to one another because then I would have more than one loop, or worse, fragments that aren't loop at all. So they don't connect. Now this is connected to here, so it must go around the 3 this way or this way. And I can see from inspection it doesn't go that way because it would have nowhere to go. So it must go this way. And indeed it can't go here or here, so it must go up at this point. And again, I still don't want to connect a small loop here, so it doesn't come across, which forces this up here. Now here, this 3 can't come across, it must go up here, which forces that 3 as well, and indeed it must now connect across here to build this segment here, which must not stop there, it comes out. And now we have another corner for this 3, so that goes like that. Now let's see what we can do next. Let's have a look. So this 3 here must go up, there's nowhere else for the loop to go at this point. And this must extend up here and this must extend out here. Now this 2 square here has only got 2 possible places for the lines to connect, so they must go like that. Now if we look at the top left of the grid here, it could go like this, but if it did, this 2 wouldn't be solved, so it must go up round here like that. And now this loop here must connect out, that's blocked because of the 1, so it comes across here and the loop must connect here. Now look at this 1 clue. It could go like that, but the loop would be stuck, so it must go like this. And then here you can't go in, you can't go past a 1 clue twice, so it can't go around a corner, so you can always block off a forced corner on a 1 clue. It must come down here. This 1 is already fulfilled, so this is empty and that must go here. And now similarly the 2, it's only got 1 bit missing, so it must come up. And now we don't want these 2 bits to connect into mini loops, so this side must come down here. Now looking over here, this bit of the loop has to continue down. Now it could go right here, but if it did that, then this bit here wouldn't connect. So we know these connect. And similarly, for similar reasons, this segment here can't be the case. So this 3 must connect like that, and because the 1 is finished, it must connect up. Now at this point, we've got quite a lot of the loop connected already. So let's review. We've got a loop that goes, well, it's not a yes a loop. We've got part of a loop that goes up all the way around here. Oh, didn't mean to do that. And comes back round like this. Now we know it connects into all these other segments to complete the loop. Now making progress from this point is a little bit trickier because we need to think a little bit more about how everything connects. But a good place to look is over here because with all these 1s it's quite constrained. So fundamentally there's 2 ways of this 1 being used because we know it's not here. In fact it would help to mark that in. So either the loop comes down the side here or it comes up twice like this. Oh, it doesn't necessarily do that, but it would have to do this here. So let's have a look. Let's just look at the bottom here. If it went this way, it would end up doing that. But there's a problem. The 3 would go like that, and this has nowhere to go. It can't go up and it cannot go down. Therefore, we can quite reasonably conclude that this is not correct and it must go like that. Which is helpful because once we've done that, we can mark in quite a few other things, like this. In fact, we're making quite a lot of progress. That 3 must go like that. That 2 has to go like that. This has to connect across the top, this must connect into the 3. That must go like that. And then, in fact, this 3 has to connect, this has to come out. And you can see that if this went like that, this would go up to nowhere. So this must connect, this corner we talked about earlier, must connect like this. And this loop can't connect into itself, so it must go like that. And now we're very nearly done. We just need to connect this point here to this point here while solving these remaining clues and not breaking the 2 we've already done. So this has to come down here. Now this 3 is interesting. Well, actually this 1 is solved, isn't it? In fact, I don't think we need to talk about this 3 at all because this has to connect like that. And so we're done. And that's how you solve a Slitherlink puzzle. In fact, this is quite a straightforward puzzle. Some of the ones on Puzzle Mix, in fact many of them, are a bit trickier than this, and you'll probably reach a point where you need to experiment a little. But we'll look at those in some following days and talk about tactics for them at a later date. But for now, why don't you click the link, if you haven't already tried it, in the comments below, and try out this very puzzle on Puzzle Mix and see how you do.